Hi, I'm Mithilesh. Today, we're going to look into linear equations in two variables, their geometrical meaning, and behavior of two linear equations in two variables x and y. Let's see how a linear equation in two variables looks like. 5x plus 3y is equal to 8 is an example of linear equation in two variables. The two variables which I mean here are x and y rather than the numbers 5 and 3. Geometrical way is best way to understand such equations. This is 1/4 quadrant of my picturization of this line represented in a geometrical way. This line or this equation can be existing from infinity, I mean from anywhere in the line to anywhere towards positive infinity. I mean this is my negative infinity and this is my positive infinity on x-axis. So I've shown you the geometrical representation in the first quadrant, which is this. So this is my line segment of equation in the first quadrant. What I want you to catch from here is each and every point through which the line passes is a solution of the equation. May it be this point on the line, may it be this point, and may it be this point. Each and every point on this line is a solution. For example, I've pointed some of the points here like 1, 1, 0, 2.6 and 1.6, 0, which are these 3 points shown in blue markers. General form of representing such equations. General form of representing such equations are ax plus by is equal to c, where a, b and c are real numbers. Now, what happens when we consider two lines? I mean, two linear equations. What are my possible outcomes? The lines may intersect each other as I have shown here. The lines may not intersect each other as they are parallel. You can say when the lines are inclined at an angle, they might be meeting at some point, farther exterior point. May this point be their intersection. Hence, if a lines are not to be intersecting, they are parallel lines. And the lines may be coincident. Coincident is lying on one another, like this. Now I have three possible outcomes. Where will they lead to? They, along with certain parameters, determine the number of solutions which they possess. A1 by A2 is not equal to B1 by B2. Then they are intersecting lines and have exactly one solution. So A1 by A2 represents my equations represented with A1x plus B1y is equal to C1 and A2x plus B2y is equal to C2. A1, A2, A1, B2, B1, C2, C1 are represented in this form. If my A1 by A2 equals to B1 by B2 equals to C1 by C2, then infinitely many solutions exist and they are coincident, like this. They are on one another. If A1 by A2 is equal to B1 by B2, not equal to C1 by C2, then they are parallel lines and have no solution. That is, they exist in such a form. Let's work out an example for better understanding. We have been given the equations x plus 3y is equal to 6 and 2x minus 3y is equal to 12. So how do I solve them? I solve them with the elimination method. X plus 3y is equal to 6 and 2x minus 3y is equal to 12. My 3y here and 3y here are resembling something. So when I add both these equations, what do I get? I cancel both of them and my 3x would be leading to an 18. So my x value would lead me to a 6. Substituting this value in the first equation, I get 6 plus 3y is equal to 6. The 6 and 6 gets cancelled and I remain with a y is equal to 0. So What do I get here? I get here a point of intersection 6, 0. Both these lines, if represented on a graph, they cut each other, and this point of intersection is my 6, 0. Let's check out with the formula. My A1 here My A1 here is equal to 1, my B1 there is equal to 3, and a C1 is equal to 6. Let's write it down for A2, B2 and C2. My A2 there was 2, B2 there was minus 3, and C2 there was 12. So my A1 by A2 gives me a 1 by 2. My B1 by B2 gives by a minus 1 by 2. And my C1 by C2 gives me a 1 by 2. So according to the previous first parameter, I have my A1 by A2 not equal to B1 by B2, then they are intersecting lines and have exactly one solution. This is what I've got here. My A1 by A2, which is 1 by 2, is not equal to my B1 by B2, which is minus 1 by 2, and hence they have a point of intersection. Hope you've understood. Thank you.